Our next presentation is by Jason Mezelis and co-authors, Lunar ExoCam Surface Measurement of Lunar Dust Plume Migration. All right. Let's see if this works as planned. Okay. Can you guys see this? Can you hear me? We good? Yeah, that looks great.
Yes.
All right. All right. Hello, everybody. My name is Jason Mezelis with Zandif Dexit, and I am the principal investigator for a lunar payload development called Lunar ExoCam, surface measurement of lunar dust plume migration. Okay, so that's what we're going to talk about. And we have a really wonderful team here, which includes Honeybee Robotics as our systems engineer. Ecliptic Enterprises will be doing avionics, although we're not really at that point in development yet. And then we've got a great team from Arizona State University, among other things, designing a particle sensor system, which I think will be of particular interest to this crowd. So what the heck is Lunar ExoCam? Let's see. Oh, hold on. Technology. That's my email, by the way. If anybody has questions beyond this session, please hit me up at the email there. Okay, so this fancy graphic. So Lunar ExoCam, this is a remotely deployable camera and sensor payload that we're going to be ideally throwing off of a rocket on the moon in the coming years. Right now we're funded for a flight opportunities test flight with the Masten Zodiac suborbital test launch vehicle, which is going to happen in about a month. And so a little bit about this. So this, there's two aspects to this. So this basically, what we've done is taken a GoPro 360-degree field of view camera, so which is about the size of, well, it's the size of a GoPro, and we put it in this protective housing and built an injection system with it as well. This is not yet space hardened, so it'll beef up more. But what you can't see from this video is that there's two lenses on that. There's one on the front and one on the back. So this sees the entire sphere of, like, as if you were inside a beach ball. You could look at any point in it at any time, and it records everything. So that's the camera aspect. And then this is a little bit more of a current design. This is what we're going to be, we're literally building this right now to fly in October. So that's with the ejection system, and it's going to be a lateral ejection. We're going to fly two cameras, and they will also be covered with these particle sensors. These are all piezoelectric sensors. There's a number of these different individual sensors. They're all recording at a 900 hertz sampling rate at 10 bits of data for each sensor individually. And that's how we're going to capture our particle data. And the idea is, well, this is a bit of a, this is the kids at Arizona State putting this thing together. So the way this is going to work is we're going to fly middle of October on the Masten Zodiac. Masten is wonderful. Very happy to be working with these guys. And this is where we're going to mount on the payload bay. We're going to have two cameras on at a 90-degree launch angle so that they can both be relatively similarly angled with respect to where the sun's going to be, which would, you know, since it's going to be lunar morning, we want to make sure we're at the right solar angle as well. And as this thing comes down, basically, you're going to see this little animation. I don't know if that comes through or not, but yeah, we're going to just toss that thing right off the side of the rocket as it's descending. And the idea behind this is that when this thing hits the ground, we're going to be positioned to be inside the plume. So on the moon, you would have the regolith hitting you directly, and this is something that's never been measured before. We've spoken a lot with like Phil Metzger, others that have expressed a very keen interest in being able to capture this data. So that is the goal, along with, of course, the visual data we'll get. And let's see. So we have, okay, this is an animation just to give everyone an idea of the test flight. So this will be as if you were, hopefully you guys can see this animation. So we're going to go up, we're going to ascend to about 25 meters in height. And there's going to be these two cameras on there. And there's going to be a slight roll maneuver at the top to orient us properly. And then we will hover and throw the first camera off at 25 meters. Now this is rendered with a physics engine, so this is pretty accurate. All right, thanks. And then as we're descending, this is the one that's really going to simulate what the lunar ejection would be like, because it would be descending during the descent of the lander in the final vertical stage, as you see here. So 25 meters and 15 meters is what we're testing in Earth gravity. And those cameras will be activated prior to release. So they're going to capture the whole landing sequence and then the particle sensor. We don't have the Plume rendered yet in here. We're still putting this together, but that just gives everyone an idea. And then that's it. You can see it's about the size of a basketball there. And it's time to fly, and looking forward to having in a month or two, we'll have some good data and we'll be able to see how the particle sensor system activates and works. And I welcome anybody's thoughts or questions, especially regarding the particle sensor system, as far as what folks would like to see, what kind of data you'd like to see retrieved. That is it. Thank you all for your time. Thank you.
Thank you.